Bismillahirrahmanirrahim. Before we do more exercises, on solving the linear differential equation using integrating factor, let's recall back on the steps. The very first step, you have to be able to recognize the p. You have to arrange it like this, a dy dx and a function p attached to the y equivalent to a function q. After you have recognized the p, then calculate the integrating factor using this formula. So somehow you need to memorize the formula, and in our first lecture we have proof on how to get to this formula, right? After you have got that, then you are to multiply this integrating factor there with all the terms. So as when you multiply the left hand side, it will become like expansions of the product rule. So there we recognize what is the mu and the y, because when you expand this product of the derivative of mu times y, it becomes mu y prime dy dx plus the mu prime and y. So that's how we can combine it. And then after that we bring this dx on the other side, multiply by dx, and hence we can integrate both sides and then get the mu y and solve further the y. So we are to follow these steps. So these are few class questions, the class exercises given in our workbook. So let's compare work, but before we compare work, it's good that you try them first. Question number 1. Solve the initial value problem. Initial value meaning you are given a boundary or an initial condition. When x is 1, the y is 2. So the differential equation that we have is x squared y prime meaning dy dx plus xy equivalent to 1. Let us get the y. So ready? Let's compare work. So I'm rewriting back the question just now. We are to follow the steps by step work. So the first step, we have to be able to get the p and getting the integrating factor. There I put the formula for you. So it's a formula here. The formula is actually mu as e power integrating p with respect to dx. So what is p? So in order to get this formula, this formula. So how to get the p there? We have to get into this format. Here we have x squared and dy dx. So before, in other words to say, you are not able to write or to read your p from here. So you should reformat or rearrange such that you are to get it in terms of this format. Only dy dx is there to be able to recognize your p. So what we should do is we divide all with x squared. So there over here we only have like dy dx. So hence over here we divide it by x squared as well. We get 1 on x. Y. And then over here we divide it by x squared and we get 1 on x squared. So hence from there we are able to recognize our p, right? So that is our p here. That is the p. So after you have got the p, and then use the integrating factor, the formula. So it's an integral of our p. P here is 1 positive 1 on x. So integrating 1 on x is easy. It is ln x. Don't put down the c just yet. So and then we are to this is can be simplified using the law of log e power ln x is actually x. So you have to get this correct first. It has to be correct, as one statement must be correct. So we got 1 mark. Next, step number 2. After we have got the integrating factor, which is x, step number 2, you are to multiply all into this equation with the mu or the x in this case. So we multiply here with the x, multiply x, and multiply x there. Okay. And then we simplify and combine the left-hand side value. Okay. So as we simplify, and then here xx becomes y. Okay, such that, okay, if the x is x and the y is y, so the derivative of the x on y, we can check, okay, using a product rule. The derivative xy is x y prime plus y x prime dx dx, which is 1. So this is correct, yeah? Okay, so we can combine it, right? So there's a mark there for us to combine it, okay, correctly. M1. Then step number 3, what should we do? After you have got this, okay, we rearranging it, multiply by dx, and okay, so we integrate both sides. So we integrate both sides and solve the integral of ds. Okay, this is the s, which is the x and y, and on the right side, integrating 1 on x, we get dx, right? So hence, we are now able to solve our y. Let's write down the y. So the y there is ln of x must be positive plus constant of integration. I put it on the right side over x. So that is our solution, okay, for this linear differential equation. So up to that level, M1 for you to integrate both sides, and A1 your answer in terms of the constancy. Okay, next we are given a condition, first condition such that when y1 is 2, meaning when x is 1, y is 2, let's substitute the values. Okay, so here the y is 2, okay, ln 1 is 0 plus c over the x, which is 1. So this is 0 plus c over 1, so hence we solve the c. So 2 marks for you to substitute first and your final answer. Alright, so we have solved our equation. Let us count how many marks do this question carry. So it carries 6 marks, starting by recognizing the p and get the integrating factor, okay, 1 mark. And then you are to multiply all with the integrating factor, which is the x, and combine it, okay, using a product rule, okay, but the other way around, okay, u x y prime plus y x prime, okay, so this one. And then you are to integrate, okay, rearrange, okay, put the dx, multiply dx over there, and then integrate both sides, show it, integrate, and then solve the integral. It's a very simple integration such that you can produce your answer straight away, okay, A1. And then because you are given initial value there, x is 1, for y is 2, so we substitute, and hence we get the final answer. Alright, okay, so compared to your work, let's see how much mark you get. Okay, thank you.